This video, we're going to use factor trees to find the prime factorization of some numbers here. We talked last time about what numbers are prime and what numbers are composite. And we're going to be dealing with prime factors in this class that are between 1 and 100. So we're going to keep using this chart over here for a little bit. Let's go ahead and let's try and break 15 down into some smaller numbers that are prime numbers, and we're going to stop when all the factors that we've broken it down into are prime numbers that can't be broken down anymore. So we know that 15 is divisible by 5 since it ends in 5. 5 goes into 15 3 times. 3 and 5 are both prime numbers that are circled. So I'm done. I have what's called the prime factorization of 15. 63. We're going to break that down now. It can't be broken down by 2 because it doesn't end in 0, 2, 4, 6, or 8. But I see that 3 can go into 63 evenly. 3 goes into 6 2 times. 3 goes into 3 1 time. And then I look at 21, and 21 is a multiple of 3 again. It's 3 times 7. And so again, I'm circling my prime factors here that I'm going to keep. So this one is 3 times 5. This one is equal to 3, and we've written exponents already at this point for repeated factors. So 3 squared times 7 is its prime factorization. Our next one is 126, and it's going to be 2 times 63, which is, and then we have 63 broken down already for us, was 3 times 21, which was 3 times 7. So this is 2 times 3 squared times 7. I'm going to come down here to the next row to work on the next two problems. We've got 42 is 2 times 21. And 21 is 3 times 7. So 42 is 2 times 3 times 7. We're using this multiplication dot now between factors. That's, instead of using an X, we're going to use the multiplication dot most of the time when we're talking about prime factorization. It's just another multiplication symbol in math. 700 is going to be 7 times 100. And then 100 breaks down into 10 times 10. And each of those 10s is 2 times 5. And these are prime numbers. These were prime numbers here. So I've got 2 2s, 2 5s, and a 7 in 700. And that's how I'm going to find the prime factorization and write it in exponential form for a given number. Now, if the number that they give me can't be broken down anymore because it's a prime number, and there are no factors other than 1 in itself, choose the option that says that it's a prime number and can't be broken down, or write on your paper prime, or write the factorization just as 1 times the number itself, if those are the only factors, if that's what your teacher tells you to do. Okay. That's it for this video. We'll come back next time and start applying these factor trees to help us with fractions. They're going to help us with reducing our fractions to get them into simplest terms. They're going to help us find greatest common least common denominators in our fractions to be able to add and subtract fractions with unlike denominators. So these factor trees are going to be really powerful tools to help us here in just a little bit.